Hi everyone, welcome back to our channel. Today we are diving back into our series on running the grid smoother via the command line terminal. In this video, we'll be tackling a common scenario, rerunning the grid smoother when you have a new variation of a parametric surface. Specifically, we are looking at replacing surfaces within an existing topology. Our goal is to leverage the smooth grid we generated for our baseline surface shape and adapt it to a new variation. This means we won't need to start from scratch. Think of it this way. We already have a high-quality converged grid for our initial design. By replacing only the modified surface in the topology, we can rerun the grid smoother and focus its efforts solely on that updated surface. The grid for the rest of the domain will be smooth, high-quality grid already, so that time is saved. This approach offers a major time-saving advance. The grid smoother essentially restarts from the baseline grid, and its computational power is concentrated on accommodating the new surface variation. The rest of the domain retains its smooth, high-quality grid, saving us valuable processing time. This technique is incredibly useful when you are iterating on designs and exploring different geometric configurations. Base topology. We have a valid topology for baseline model of re-entry vehicle, where re-entry vehicle surface is named as reentry_capsule.tria. We have saved this file as reentry_capsule.fra. We have modified the schedule file to run the grid smoother for 300 sweeps and saved it as reentry_capsule.sch. After running the grid smoother and loading the grid file in the UI, we can see the well-converged grid with a good skew below 0.4. Replacing the surface. Now let's consider a new variation of the baseline surface of re-entry vehicle which we want to generate a grid for. We will replace the baseline surface in our topology with a new one. We can do this in two ways. One, by simply reloading the existing surface in the UI with the new surface and saving the .fra file. Two, by renaming the new surface same as the existing surface. Here we copy the new variation in the directory. Rename the baseline reentry_capsule.tria surface file to reentry_capsule_old.tria. Rename the new surface file to reentry_capsule.tria. Now, if you open the topology, you can see that the baseline surface is replaced with new variation of it. Since we have reloaded the surface, it will maintain all the assignments, keeping the topology valid. Change in schedule file. When we restart the gridding process, the grid smoother focuses on converging the grid around the re-entry vehicle surface only, as the rest of the domain already has a converged grid. So we can get a good grid specifying the lower number of sweeps while restarting the grid smoother. We will continue the gridding process for another 200 sweeps to capture the replaced surface. Let's add this in step 4 in the schedule file as step 4-S200-W. Restarting the grid smoother. We will use the same syntax to restart the grid as explained in the previous video, which is grid topology file name -r data file. And the command is grid reentry_capsule.fra -r dump.temp. Evaluating the restarted grid. Once the gridding process is completed, click on Update to get an updated grid in the grid panel. Now we have a well-converged, zero-folded grid for the new geometry surface. The highest Q value is also below 0.4. The restart option, combined with surface replacement, offers a significant advance for gridding parametric variations by drastically reducing grid smoothing time and enhancing efficiency. We hope this video helps you understand a way to save the grid processing time for mesh generation of parametric geometry variations, maintaining self-similar and high-quality grids. Thank you for watching.